So on this next problem, I started by graphing the line. And I note that it says I have an enclosed rectangular region who has one vertex at the origin. So here it is, got a vertex at the origin, and the opposite vertex is on my line. And so I'm supposed to find the dimensions so that the area is a maximum. Now, here's what I know about the area of that rectangle. Of course, it's length times width. So now I need to figure out, well, what are the lengths and what are the widths? And so I know that this entire height, of course, is 2. And therefore, so if I call this side L, and I'll call this other side the width. And so, of course, I could find, oops, hold on one second. And of course, I know this whole distance is 4. So I could find these little tiny pieces here, like this one would be 2 minus L, and this one here would be 4 minus W. So now I want to be able to relate those, and what I notice is that I have some similar triangles, if you remember from geometry, by angle, because they are both right triangles, and they both use this angle here, so they're similar by angle. And when I say I have similar triangles, the ones I'm talking about are this little tiny one here on the far right, and the great big triangle overall that I started with. So this one right here, I'm going to outline it in purple. So now, since I have similar triangles, I can write a ratio of their sides. So the vertical side of the big triangle was 2, and that matches with the vertical side of the little triangle, which is L. And then I'm going to do the horizontal side of the big triangle, which is 4, and the horizontal side of the little triangle, which is 4 minus W. So now I have an equation I can work with. It has W's and L's, and it'll relate them. So I could get one of those variables by itself, so that I'll be able to substitute it over into my area formula. So let's see, if I cross multiply, this is going to lead me to 4L equals 8 minus 2W, and I guess I'll get L by itself, seems to be the easiest at the moment. So I'll divide everything by 4, so L is 2 minus a half a W. And so now I can plug that in place of L. So now my area looks like this. Oh boy, I'm going to get a quadratic. I like quadratics because I can find maximums and minimums. Ooh, as a matter of fact, I know this will have a maximum because it is a parabola opening down. So if I want to find the max, of course, I can take the first derivative and I'll set it equal to 0, which will give me W is 2. And if I plug this back in to this equation right here up above, then I find out that L is 2 minus 1, or 1. I just found the dimensions of my rectangle. So I can say it's 2 by 1 with the width first. Awesome!